my name is Michelle Wynn, and my project is called The Effect of the Amount of Time of Nutrient Starvation on the Lipid Production in Algae. Our extensive use of fossil fuels has had destructive effects on the environment. With algae, which is easy to grow and won't take up acres of land, I believe that we have found our solution. Algae was found to have a much higher yield of biofuel with a lower need of resources, unlike first generation and second generation biofuels. So why don't we just switch to algae already? The production of fertilizer that's needed to cultivate algae for the entire United States would be incredibly costly. So my project is attempting to alleviate this financial issue by increasing the yield of lipids while decreasing the amount of fertilizer needed through nutrient starvation. So with my project, I'm attempting to see which method of nutrient starvation would be the most beneficial. So my hypothesis is if I begin nutrient starvation 3 weeks into algae growth, then the lipid yield will be higher than if I begin it at 2 weeks or at 4 weeks. So my independent variable is the onset of starvation, while my dependent variable would be the amount of lipid yield. Procedure, I got 3 sterilized containers filled with 200 milliliters of pond water. I added a drop of nutrients into the pond water, added 4 milliliters of chlorella into the water, added CO2 boosters, 1 drop of nutrients every single week, and after 2 weeks, began the nutrient starvation in container 1. After 3 weeks, I began in container 2, and after 4 weeks, I began the nutrient starvation in container 3, and I starved the algae for 1 week each. After starvation, I drained the water from the algae by pressing it with the coffee filters, and I crushed the algae cell walls to extract the lipids by grinding it with mortar and pestle. Then I mixed the algae with equal amounts of acetone and let the lipids float to the surface. The top layer would be the lipids, and I extracted the lipids using a pipette. Then I recorded the lipid content and compared the data. So for table 1, I have the lipid amount, table 2, I have the algae biomass, and for table 2, I have lipid amount over algae biomass to show the percentage of lipid in algae. So then I have graphs with error bars, and I also conducted an ANOVA test in order to see statistical significance. So the mean of the lipid yield was highest for the algae that was starved at 3 weeks, which would be 54.7% compared to 38.2% at 2 weeks, and then 48.9% at 4 weeks. And the ANOVA test had the F value of 14.641, and compared to the critical value of 3.89, it was greater, which means that we reject the null hypothesis. Our null hypothesis stated that there's no relation between the onset of starvation and algae lipid yield, and so we are rejecting that. Recent studies have actually already implied that nutrient starvation results in a higher lipid yield, and so starving the algae of nutrients leads to an increase in lipid production, because instead of directing energy to increase biomass, the energy actually instead goes to increasing lipid content to preserve carbon and energy. Additionally, triacylglycerol is a type of nonpolar lipid that carries a lot of energy, and so the triacylglycerol content in algae is actually likely to increase in situations such as lack of nutrients or stress environments, which leads to a higher lipid/energy yield. And as such, my research question was about at what time nutrient starvation should begin for maximum lipid yield. So pertaining to biomass, the starvation of nitrogen and phosphorus in the chlorella showed a significant increase in lipid productivity, albeit with a reduced cell size. So although the amount of lipid yield was increased, cell size was decreased. So inferring from my data, the algae that was starved at 4 weeks rather than 2 weeks had a higher lipid yield, even though the algae starved at 2 weeks had more time to produce a higher amount of lipids, because the algae starved at 4 weeks had a greater biomass. And so therefore, beginning starvation at 3 weeks was actually optimal for lipid yield. So a lot of my limitations were due to financial reasons. The amount of algae was not as much as I would have liked. I wasn't able to use a heating lamp to keep algae at the optimum temperature that it's supposed to be, which is 80 to 85 degrees Fahrenheit. Another limitation would be the nutrient solution that I used, which was highly concentrated. I would have liked to use a diluted solution instead. And so on the topic of nutrients, for future experimentations, I would like to experiment with starving the algae of different types of nutrients. Biofuels provide this exceptional replacement for crude oil. They can be produced domestically, which would end our dependence on foreign nations. They would reduce our pollutant emissions, and they can be sustained indefinitely because it's a renewable resource. The only problem with this is that it's too expensive. So when scientists work towards ending this financial issue of biofuels, we're actually working towards a better, greener future for all. So that's my project. Thank you so much for listening. Here are my sources. They're very small. I was trying to fit them all in one slide. I think you can zoom in though. So thank you.